welcome to all of the young people watching the launch. And here we see the protagonist of the evening, the launcher Soyuz, which is built of 4 stages. From the bottom to the top, you see the boosters, the third stage, the second stage, the third stage, and now frégate. We'll talk about it later. This is the fairing, which contains our satellite. On the very top, you see Sentinel 1B, the biggest one. And below Sentinel 1B, now you see Microscope, which is inside the structure which supports Sentinel 1B, 2.2 tons. The scientific satellite of the French Space Agency, CNES. And we launched 3 small satellites built by students under the ESA program, Fly Your Satellite. Our best wishes to all of the teams.
Attention pour le début de la séquence d'allumage du lanceur. Top, HR-20 secondes. Largage du mât VKM. Allumage du triétage. À tous télédéo, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Décollage. Lift-off. VS14.
We are off, hauling ourselves against the gravity of the Earth. 336 tons, the equivalent of 22 buses. And we're heading north, out over the Atlantic, and then over North Canada. So at the moment, Soyuz is burning its 5 engines, 1 on the core stage, 4 on the boosters. The boosters are doing most of the work. Their job is to get us away from Earth and defeat gravity, which makes us stick to our planet. They have a very short-lived job.
Le vol est nominal, les paramètres sont normaux.
All parameters are nominal. They have a short life. They're going to be separated, and you will see them drop on the ground just before 2 minutes in the flight, so very soon. They are powered by liquid oxygen and kerosene. If we get lucky, we should be able to see the separation of the boosters, which is a magnificent sight.
La propulsion du premier et deuxième étage est nominale.
All is nominal on board. Watch for 158. Separation of the boosters. You can't, but I can see the roar of the engine from where I'm staying. So the burn of their propellant, so we don't need them anymore. They fall back to Earth, and we are shedding weight, which is the whole trick of a launch. The lighter we are, the faster we go. So we are start to burn the second stage, or the block A. This will burn for just under 5 minutes. If you look at the trajectory, as we call it, this curve on the right upper corner of your screen, this shows the theoretical path that we are following tonight and the actual path, this white dot. So as you see, everything is nominal. We are coming now to the altitude. Look on the bottom left, where we can get rid of the fairing. The fairing has these 2 shells that protect our precious payload. They protect it from the acoustic vibration at liftoff, the very loud noise, the roar of the engine, and from the friction, the resistance, the pressure, then the air layer are here we go, are exercising on the launcher during the ascent. Here they go, we have jettisoned the fairing. We don't need it anymore. We are now outside the atmosphere. And if someone asks you how much time it takes to go to 700 kilometers, answer 23 minutes. This is what it will take us today. So probably less than what it takes every morning to go to work. So we have seen our satellites for the first time, and this is always an emotional moment, even when it is only computer-generated images. Here we see the teams. I'll tell you, they've really worked hard in all these days, and they kept the concentration, and today is the day.
La propulsion du deuxième étage est normale.
So we're coming to the point where the second stage will be shut down, will be falling away, and we will start igniting the third stage. Here we go. We are now burning the third stage. So we launched Sentinel 1A 2 years ago, and we're launching its twin tonight.
Séparation du deuxième étage.
And you have heard Professor Liebig, the director for Earth Observation Program at ESA, explaining which wealth of data Sentinel 1A is already delivering in its 2 years of operation. And with the arrival of its twin that we're launching tonight, and with increased exploitation of Sentinel 1A, by the end of the year, we will deliver to the user 3 times the amount of data we are delivering today. And you've seen, this is the moment of the third stage engine shut down. We have separated it, and now it's Fregat who takes us to orbit. Its job is to deliver our satellite to their drop-off point in space. Tonight he has to deliver 3 separate missions, and it's going to take about 1 hour to do that, so quite a journey. Let's explain what will happen. First, we're going to climb to about 700 kilometers altitude, which is the drop-off point of Sentinel 1B. Then we will go down, and we will go down by more than 200 kilometers to fly a satellite. We will then climb up again to just above the 700 kilometers when we left Sentinel 1B to separate Microscope. You've seen now that the first burn of Fregat has started. This lasts just over 10 minutes, and the satellite is now being acquired. Sorry, not only the satellite, the upper composite Fregat has just been acquired by the station of Saint-Hubert. Our flight path tonight takes us north, so we are over northern Canada, and it is there, not yet, where we will separate Sentinel 1B. Why are we flying north? Are we flying north because we are launching an Earth observation satellite, Sentinel 1B. An Earth observation satellite have to be able to cover the complete globe, and they do that by being placed on an orbit which goes over the poles and exploiting the rotation of the Earth beneath them. They cover the whole globe. It's like peeling an orange slice by slice. So Sentinel 1B was built by a consortium of European companies led by our friends at Thales Alenia Space in Italy. They are great experts in Earth observation and in radar system. So they're very proud of their contribution to understanding our planet. Space is about cooperation. Space has no frontiers. Copernicus is the result of a successful cooperation between the European Space Agency and the European Commission. And Sentinel-1 is an example of industrial partnership between two companies, Thales Alenia Space and Airbus Defence and Space, that any other day where they do not work on Sentinel are competitors. Sentinel-1B is part of a huge program called Copernicus. It's implemented by the European Space Agency for the European Commission, and it consists of 6 families of Sentinels called satellites. Several families because we need several techniques, several technologies. Copernicus is a system that aims at performing a complete health check of our planet. This is why we use very many different technologies, like the difference between a blood test and a full health check. So Sentinel-1A is really changing lives in a very tangible way, and its twin, Sentinel-1B, that we're launching this evening, is going to make those services even better. So we have heard about some of them, but the list of applications of Sentinel-1 is almost endless. It carries an advanced radar. This means it can see through the clouds. It can take measurement day and night. It does not need the illumination from the sun. This makes this mission particularly suitable and helpful for natural disaster and emergency crisis situations such as earthquakes and floods. But the list of applications continues. It is extremely good at detecting very tiny movement in the order of millimeters, imagine, from a 700 kilometers altitude over terrain. We call it subsidence, either due to extraction of gas or fracking or natural subsidence itself of the terrain. It is capable of monitoring the stage of growth of rice, and rice is among the 3 most consumed crops to feed world population which is constantly growing, will reach 11 billion by the end of the century. Over the ocean, it adds navigation by providing information about winds. It measures waves. It can monitor oil spills, both from ships and oil platforms, provide assistance to ship routing and fisheries. And I could continue. So very many applications, each of which taken individually would justify the investment. And Sentinel-1 delivers all of them. And here we come to the point where Frégate is switching off its engine for the first time. This is the end of the first and longest burn. Look at the bottom left side of your screen and you will see that we have reached the right altitude, the orbit of Sentinel-1B. This is the right altitude to complete the first task separating Sentinel-1B. What is happening at the moment is that we have entered what we call a ballistic phase. It will last about 3 minutes and 20 seconds until we come to the point of separation. It is ballistic, it means it is without propulsion.
Extinction du frégate.
We are traveling high enough and fast enough to cruise without the engine. What you're seeing Frégate doing at the moment is what we call orientation maneuvers. This means that Frégate, which is a very versatile machine,
Début des manœuvres d'orientation au profit de Sentinel-1B.
Frégate will now orientate itself in order to
Acquisition
be
de la télémesure lanceur par la station de Saskatoon au Canada.
So far, everything is proceeding nominal. So we were saying Frégate is now orienting slowly itself to prepare to deliver in orbit Sentinel-1B. It will deliver Sentinel-1B not only just on the right orbit, but with the right attitude with respect to the Sun. So directly in its own operational orbit. Frégate is an extremely versatile machine. It was originally designed as an interplanetary probe in the 90s. It first flew on Soyuz in
Tous les
2000.
systèmes bord fonctionnent nominalement.
Everything is nominal, and this is just we want to hear tonight. Frégate is capable of switching the engine on and off 20 times, and this evening is going to do it 5 times for us. It can take passengers wherever they need to go. It's an excellent taxi, first-class taxi. So, let me explain now that we're coming close to the first key milestone of the evening, a crucial moment for the Sentinel 1B team. It is the moment of separation of Sentinel 1B. It is scheduled for 23 minutes and 35 seconds in the flight. We are coming close to it. The confirmation of the separation has to go via a number of technical checks that must be very accurate. And because Soyuz and Frégate are a Russian launcher, let's not forget this, all these checks have to go via Moscow. This means that it may take a little bit before having the official confirmation here in the mission control room of the separation. And here we are. So, Sentinel 1B